There are 7 steps that you need to use in order to add vectors graphically. You must first identify the vectors, identify the scale you're going to use the scale conversions, add vectors tail to tip, draw and measure the resultant, use scale conversions, and measure the angle and direction of that angle. We're going to go through these steps and do an example problem of how to add vectors graphically. So this is the example that we have. A person walks 9 kilometers east and then turns and walks 12 kilometers north. What's the resultant displacement of this person? The first step is to identify vectors. What we're going to do, we're going to identify the vectors. The first vector we're going to call D1. D1 is equal to 9.00 kilometers, and that is going east. The second vector we have, I'm going to call D2. That's going to be 12.00 kilometers. That's going to be going north. Okay? Now what we need to do, that was the first step, identify vectors. Now we need to identify the scale, because these distances, kilometers, cannot fit on this piece of graph paper. So we need to scale them down so they'll fit on this piece of graph paper even when we add them. The scale that we're going to use for this one, we need to make sure the scale is clearly identified. The scale is going to be 1.00 centimeters, is equivalent to 3.00 kilometers in reality. So this is our scale distance on paper. This is our actual distance in reality. So now we've identified the scale. The next step is we're going to use these scale conversions to convert our actual distances into a scale distance that we can use on this paper. The way we do that, we're going to do one conversion at a time. The first distance is 9.00 kilometers. We're going to use our conversion process. Dimensional analysis to convert kilometers to centimeters in our scale. We have 1.00 centimeters is equivalent to 3.00 kilometers. That way kilometers cancel. And we should get a value of 3.00 centimeters for D1. This is our scale distance that we'll be able to draw on the graph paper. For D2, our distance in actual is 12.00 kilometers. We'll scale that down. Again, 1.00 centimeters is equivalent to 3.00 kilometers. And we'll end up getting 4.00 centimeters for our scale distance. So we've used our first 3 steps all the way to the scale conversion. Now we're going to add vectors. We always add vectors tail to tip. Remember, the order in which you add the vectors does not matter. We can have D1 plus D2 or D2 plus D1. We must draw the vectors in their correct direction and their correct magnitude. I'm going to start about here, drawing the vectors. So you pick some reference point on your paper that you're going to draw the vectors. Now I'm just going to draw D1 first. And D1 to scale at 3.00 centimeters. So I'll make sure this is lined up exactly going due east. I'm going to draw this exactly 3.00 centimeters. And I use my metric ruler, put the 0 on my reference point, and this is my 3.00 centimeters. I make sure my vector is exactly 3.00 centimeters, and the vector is an arrow, not a straight line. And this is my D1, which is in actuality 9.00 kilometers. So on the scale, 3.00 centimeters. Then you add the other vector. This is the tail of the first vector. This is the tip of the first vector. You take your second vector, which is 12 kilometers, but in scale 4 centimeters, and you add it tail to tip. So I'm going to take the tail of this 12 kilometer vector and add it to the tip, or start drawing it on the tip of the first vector that I drew, and it has to go due north. So in order to make sure it goes due north, I'm going to put my protractor here, line it up with the tip of the first vector I drew, make sure it's aligned correctly, and due north is 90 degrees or towards the top of the paper, so I'm going to put a dot right there. Then I can take my ruler and make sure that I go exactly 4 centimeters due north. I'm going to put my 0 point on the tip of this vector, and I'm going to go to exactly 4 centimeters, being very, very careful my drawing. Being as accurate and precise as I possibly can be. That's the 4 centimeters. So you can see that. Draw the tip of the arrow right there. And so now this is my D2, which is 12.00 kilometers. So now I've added the vectors tail to tip, gone through all those steps. I now need to draw and measure the resultant vector. Remember, the resultant vector is always drawn from the tail of the first vector to the tip of the last vector added. In this case, we've only added 2 vectors, so the resultant is drawn from the tail of the first to the tip of that second vector. I take my ruler and draw as accurately and precisely as I can the vector from tail to tip, and the direction is always towards the last vector drawn. So this is my resultant displacement. So I'm going to say d sub r is my resultant. I need to know what the magnitude of that resultant is, so I'm going to measure it from tail to tip, and it is going to be, like, it's right on the 5, so I'm going to call that 5.00 centimeters. So my resultant vector is 5.00 centimeters to scale. And now what I've done, I've drawn and measured the resultant vector. I'm now using my scale conversions to convert the scale distance to the actual distance. So now I want to cancel out centimeters. Again, my scale is 1 centimeter equals 3 kilometers. I want my centimeters to cancel, so I'm going to put 1.00 centimeters on the bottom, 3.00 kilometers on top. The centimeters cancel, and I should get 15.00 kilometers for my resultant vector. That's the magnitude. So I can put over here my resultant is 15.00 kilometers. That's part of my solution, only part of it. The last step I need to do, so I've used my scale conversions to convert the scale distances to actual distances. I now need to measure the angle and identify the direction. The angle of the resultant vector is always drawn from the tail of the first vector towards the tail of the resultant vector. So this is the angle that I'm going to measure right here. We call that theta. So I use the protractor, line it up so the 0 mark is at the tail of the first vector, and that is aligned properly, vertically and horizontally. And so now I need to measure this angle, and since this protractor is calibrated to the nearest degree, I should be able to measure to the nearest tenth of a degree. See how close I can zoom in there? And so this vector is right here. So this is 50 degrees, 51, 52, 53, almost 53, not quite. There's 51, 52, 53. So I'm going to say this is 52.9. That's the best I can do. So the angle is 52.9 degrees in this direction of this angle. This way is east. This way is east. Back up so you can see. This way is east, and I'm going up this way, which is north. I'm going to say this is 52.9 degrees north of east. So my answer is 15 kilometers at an angle 52.9 degrees north of east.